Okay, so like I said, this note sheet that we're going to fill out goes on page 20 when we're done, okay? Everyone should have the pink note-taking sheet that looks like this. This is what you guys are going to be taking notes on today, all right? So today we're going to be learning about how to take a situation and use an inequality to either represent the situation with an inequality or a graph, or maybe solve a problem by using an inequality or a graph, okay? So, on your note-taking sheet, on this first problem set, it says write and graph an inequality to represent each situation. So we're going to look at each situation and write and graph an inequality for it, okay? So, as we go through the notes today, we're going to be writing down some key words that are going to help us to figure out which inequality symbols we should use, okay? So up on the top of your paper, we're going to do like a little section where we're going to write down some keywords up here, okay? Now, one of those keywords is in this first problem here. It says you can spend at most $40 when you go out Friday night, okay? So, if we have the keywords at most, what does that mean in this situation? Like, if I'm going out on Friday night, can I spend $10? Yes. Can I spend 20?
Yes.
30?
Yes.
40?
Yes.
50?
No.
No. So, I have to stay under 40. Could I spend exactly 40 though?
Yeah.
Yeah. Okay. So, when I see the words at most, it means less than or equal to. Okay, these keywords tell me to use this inequality, all right? Now, so I'm going to pick a variable. I'm going to use S for what I can spend. It's going to have to be less than or equal to 40. So I've written my inequality, and now I'm going to draw a number line to represent it, okay? So for my number line, I probably don't want to count by ones. That would not be very good, right? Maybe I'll count by tens. Okay. And now I need to think about, do I want to have an open circle or a closed circle on 40? Closed. Okay, which way is my shading going? To the right or to the left? Left. Okay. That's it for that first one. Okay, now, some other keywords that mean the same thing as at most, okay, would be like if I could replace the words at most with maximum. You can spend a maximum of $40. Wouldn't that mean the same thing? Okay, so if you ever see the keywords maximum, that also means less than or equal to, okay? All right, so let's take a look at the next one, okay? So the next one says the minimum GPA to be accepted to Harvard is 4.0, okay? So you have some keywords here. They are minimum, okay? What does it mean if I need a minimum GPA of 4.0? Can I get accepted to Harvard if I have a 3.9? No. What if I have a 4.2?
Yes.
What if I have a 4.0?
Yes.
Yeah, okay, that's what this is saying. It needs to be this number or more, right? Okay, so, yeah, my inequality is going to be greater than or equal to when I see the word minimum. That key word means greater than or equal to, okay? Now, let's go ahead and write an inequality to represent this. So my GPA is going to be greater than or equal to 4.0. All right. Okay, let's draw a number line. Okay, open or closed circle on 4.
Closed.
Okay, closed. Shading To the right or to the left?
To the right.
Yeah, we want the numbers bigger than 4. It's going to the right. Okay. Now, another word that would mean the same thing as minimum, like if I replace the word minimum, I could say I need a GPA of at least 4.0, right? So when I see those words at least, that's another word for minimum or for greater than or equal to, okay? So if you ever see the words at least, that means the same thing as minimum, all right? Okay. Any questions so far on the 2 examples we did? Okay, all right. Let's look at this next part, okay? So in this next part, we have like one situation for all of these parts, okay? So here's the situation. It says Brent is ordering books for a reading group. Each book costs $11.95. If he orders at least $200 worth of books, he will get free shipping, okay? So we know each book is $11.95. We know he's going to order at least $200, okay? So he can get this free shipping. All right, in part A, it says choose a variable for the unknown quantity. Include the units. All right, so what do I not know? Do I not know the price, or do I not know how many? I don't know how many, right? So I'm going to let my variable represent the number of books he orders. So what variable do you guys want to use?
B.
Okay. So let B represent the number of books he orders. Okay. All right, now it says write an inequality from the verbal model. So every book is $11.95, right? So let's write $11.95 times B, so times the number of books, is going to be at least, so look back at your keywords. What symbol for at least? Greater than or equal to $200, right? All right, so there's my inequality. Okay, now, part C says complete the table to find some number of books Brent can order and receive free shipping. So they've done one example for you, okay? And the example they did for you, they guessed 15 books, and they're checking, is this a solution? So look at what they got. $179.25 is greater than or equal to 200. Is that true? No. So is he going to get free shipping if he buys 15 books? No. Okay. Let's check and see if he buys 16 books. Okay, so some of you already multiplied on your calculator. You told me you got 191.2, so $191.20. Is that greater than or equal to 200? No, I'm actually going to put a slash through that because it's not. That's not true, right? And so no, it's not a solution. He's not going to get free shipping. Okay, let's see if he buys 17 books. What happens?
203.15.
Let's see. So you guys multiplied on your calculator. What did you get?
203.15.
$203.15. Is that greater than or equal to 200?
Yes.
Yeah. So will he get free shipping now?
Yes.
Yeah. Okay. All right. And then last, what do you predict if he buys 18 books? Is he going to get free shipping?
Yes.
Yeah, definitely, right? If he got it for 17, I should be thinking that for 18, he's definitely getting it. But what is the cost, actually?
$215.1.
And how many cents?
0.1.
0.10, so, and 10 cents. Okay. All right. So once he buys 17 books, he's getting free shipping, right? Okay. Now, they picked some values and they guessed and checked to figure it out, okay? But let's say I don't want to guess and check because there's a lot of numbers I could guess and check. They kind of got lucky that they got close in the beginning. Let's say I just want to solve it. So another method is to take my inequality I wrote down and solve it. So how would I actually solve this inequality? What is the opposite of multiplying? Divide. So we could just divide on both sides. And when we divide on both sides, don't we end up getting a decimal? What do you guys get?
16.7364067.
La 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 la, right? 16.736, blah, 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 blah. Okay? Now, let me ask you guys, are you going to buy 16.736, la, 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 books? Is that a number of books that you will buy?
No.
No. Okay. So, you need to think about this in the context of the problem. Okay? If you were able to buy exactly this amount, this would give you $200 exactly, right? But you can't. You either have to buy 16 books or 17. So what do you need to do to get that free shipping? 16 or 17? Yeah, round up, right? Okay. So we're going to say that 17 books gives us free shipping. Okay, are there questions on what we did right there? Any questions on that? Okay. All right. Now, in that problem, I think Brent's living in the dark ages because if I were Brent, I'd just go on Amazon Prime and then it's free shipping with 2 days. But I don't know. All right. Maybe Brent doesn't have an Amazon Prime account. I don't know. Okay. Let's look at another problem. Okay. So, all of these questions are in regard to this situation here. Okay, let's read over the situation. It says, Franza has a prepaid cell phone that costs $1 per day plus 10 cents per minute she uses.
Wow.
She has a daily budget of $5 for phone costs. Write an inequality to represent the situation. Okay, so what's some of the key information they gave us here? She has to pay $1 plus how much? 10 cents per minute, right? What's her daily budget? $5. So let's think about what that means. Can she spend $4?
Yes.
Can she spend $5?
Yes.
Can she spend $6?
No.
No. So we're using less than or equal to, right?
Yes.
Okay. So her cost is $1 plus 10 cents per minute. What should I do? Right? M, okay. And that's going to be less than or equal to $5, right? I'm going to say that my variable M is equaling the number of minutes. Does that make sense? Okay. So I've written an equality and I've labeled my variable. M was the number of minutes, right? Okay. So the next part says, what is the maximum number of minutes she can use and still stay within her budget? Show your reasoning. So what I want to do is actually solve this to figure out, okay? So let's go ahead and I'm going to rewrite this down here because part of my reasoning is going to be my work, okay? So what's the first thing I should do to solve that?
Subtract one on both sides.
Okay. what's the next thing I should do?
Divide by 10.
Yeah, let's divide by point. It's not 10, it's, because it's 10 cents, right? It's point 10 or 0.10, right? Okay, so what do you guys get when you do that?
40.
4 divided by 0.1.
Oh, point
40?
Yeah.
Yeah,
Okay.
I got 40.
Oh, yeah, 40.
Because if I got a decimal, would that make sense in my answer?
No.
Because remember, it's representing a number of minutes, so that wouldn't probably really make sense, right? Okay, so what is this saying here? It's saying that, what is M representing? The minutes have to be less than or equal to what?
40.
And then she's within her budget, right? So here where it says describe the solution set, we're going to basically write that in words, okay?
Okay.
She can use 40 minutes or less and stay under her budget, right? Or within her budget. Okay. All right, are there questions there?